Picture this. You've recently gone into chess, and you decide to join your university's chess club. You show up to the first meeting and see that everyone is using these official looking chess clocks. You can get by with a phone app, but it's not the same. And instead of buying one for $15, you decide that you will make one from scratch. Hi, my name is Blake, and this is exactly the situation I found myself in when I started at UCF 2 years ago. I'm studying electrical engineering, so I thought this would be the perfect way to put the skills I was learning to the test. I had to put up with just using the app until I had the skills and the time to make one myself, but it all finally came together this summer. It all started with a simple prototype in Tinkercad. Once I verified that all the connections were right, I built it on a breadboard and expanded upon the embedded code. I decided on using an ESP32 microcontroller because of its small size and cost, and because I already had one. I also decided on using an LCD display because it was the perfect size for this project. Once I got the prototype to a state I was happy with, I went straight into the CAD. In my previous projects, I had tried many different PCB design softwares like KiCad and Eagle, but I wanted to continue to broaden my horizons, so I decided to try a new one that I heard is widely used in industry, Altium Designer. Luckily, I was able to get a free student license and get right into learning. It was very straightforward to learn since I already knew the basics, and before I knew it, I had a complete design. I decided to use two separate circuit boards, with one connecting to the power supply and the microcontroller, and the other housing the buttons and LEDs. After I sent in the order to the manufacturer, I was able to get to work on the mechanical CAD for the case. I went with a typical chess clock design with a rectangular base and a slanted face for the display, and sized everything to fit my circuit boards perfectly. Once I got my circuit boards in the mail, I was excited to get straight to work. But I quickly noticed a huge issue that I regrettably didn't realize before ordering. Somehow, many of the through holes for the header pins on the microcontroller board ended up shorted to the ground plane. This is basically totally impossible to fix without having an entirely separate board. So, my two options were to order another PCB and spend even more money on this simple project, or use a perfectly sized perf board that I happen to have. Obviously, I went with the second option, which ended up being much more of a challenge than I expected. After hours of fighting with my soldering iron, I got all of the connections accounted for, and it worked. Then, it was time to test my CAD designs by 3D printing them. This happened to be even more of a struggle, and there were a few times when I was tempted to give up and just build the case out of Lego. But after many failed prints, I got parts for the body, face, and back that I could be happy with. It was at this point I realized that I would need to graduate from my simple prototyping wires that I had been using thus far, and move on to cut and sized wires so everything could fit into my new case. Once I did this, added some buttons, and did some final debugging, the clock was fully functional. I couldn't wait to test it out at the chess club, so I played a friendly game against my roommate to test it out. Here it is. I'm super happy with how it turned out. Despite the problems with the printing and soldering, it worked just how I imagined it would. I've learned so much about the engineering process through this project, and this just makes me even more excited for what problems I'll be able to solve in the future.